Welcome to Engineering Studio with Dr. Mohammed Tahir. In this video, I am going to introduce you with our latest article published in Results in Engineering, and it is published in January 2025. So this article is related to the production of lightweight recycled brick aggregate concrete incorporating EPS beads, and its prospective application is for the masonry units for the purpose of partition walls. Because in case of partition wall, the load requirement or the strength requirement for the masonry unit is not too much. It is about 4.14 megapascal, and we also have two other requirements like heat isolation and sound isolation. So if we use EPS beads in concrete, so we can produce lightweight concrete, and it will also improve the heat isolation as well as sound isolation. So based on that concept, we introduced EPS beads to produce the lightweight concrete. And we also introduced some other waste materials like construction and demolition waste, some used cooking oil and coconut fibers. So let's see what we have done in this paper. This study aims to develop lightweight eco-friendly concrete for masonry units by incorporating recycled brick aggregate, EPS beads as partial replacement of fine aggregate. It also uses fly ash to reduce the carbon footprint as a replacement of cement. It also uses the used cooking oil as a sustainable substitute for the conventional admixtures, which are very costly. Moreover, it uses coconut fibers to enhance the mechanical properties of the concrete, especially the tensile strength. So in this study, we produce the lightweight recycled aggregate concrete incorporating coarse recycled brick aggregate, fine recycled brick aggregate, EPS beads as a replacement of fine aggregate, coconut fibers to improve the tensile strength, cement as a binder, and fly ash as a partial replacement of cement. And we also used some super plasticizers to achieve the workability, and we also replace this admixture with the used cooking oil to improve the workability of the concrete and also to utilize this waste material. And our aim was to produce a concrete which is lightweight, and as per ASTM C129, the density of lightweight concrete should be between 1400 kilogram per cubic meter to 1680 kilogram per meter cube. Here we made some trials to produce the concrete with the required density. We played with the quantity of EPS beads so that we can get our required density as well as our required strength. Then we performed some mechanical properties tests as well as we performed some durability tests like cyclic bonding in 5% sulfuric acid solution and cyclic bonding in supersaturated brine solution. So then I will jump to the conclusion of this study. So we also performed some cost analysis as well as the environmental impact like the embodied carbon. So we also calculate the embodied carbon for this light recycled brick aggregate. So here we can see incorporating fly ash as a replacement of cement can significantly reduce the carbon footprint. So if we see the conclusion, so we can see that fine aggregate in the range of 50% to 67% can result in the lightweight concrete. So lightweight concrete means its density should be less than 1680 kilogram per meter cube. Moreover, if we see the durability, so lightweight recycled brick aggregate concrete using EPS beads was largely affected by acidic environment. So its durability was less in acidic environment. But we can improve the durability in acidic environment by incorporating fly ash. So when we use fly ash as a replacement of cement, so its durability was significantly improved, both in acidic as well as saline environment. Moreover, the used cooking oil, so it improved the workability, meaning it effectively substitute the conventional or the commercial admixtures without affecting the strength as well as durability of the concrete. So if we see the cast and the embodied carbon, so using EPS bead as well as fly ash, we can significantly reduce the cast as well as embodied carbon of the concrete. So if we see the prospective application of this study, so this study can be vital for the high-rise building. So if we use these lightweight masonry units as a partition wall in the building, so we can reduce the weight of the structure. So as a result, its seismic strength will be, or seismic performance will be improved. Moreover, the sectional dimension will also be reduced due to the less dead weight of the structure.